Introducing the Triumph-F1, an unmanned aerial vehicle designed from the ground up based on Triumph-1, the field-tested high-precision geodetic GNSS receiver with 864 channels to track all current and future GNSS satellite signals. When used on the ground, Triumph-F1 can function as a Triumph-1 base or rover. Triumph-F1 includes 4 lithium polymer batteries. Each battery includes a test button and LEDs to indicate the current charge level, as well as accessible ports for easy charging. These batteries provide power to the 8 propeller motors, which are arranged in a stacked quad configuration. On top of the F1, you'll find the power button, a SIM card slot, 2 microSD slots for image storage, a USB connector for uploading flight plans and downloading collected images, indicators for satellite tracking, UHF, Wi-Fi, Bluetooth, and GSM, a flight status indicator, a gyro status indicator, an array of flight plan indicators, and a selector button for cycling through them. The underside of the F1 houses a speaker, 4 landing gear, a sonar sensor for range finding during landing, up to 4 antennas including Bluetooth and Wi-Fi, and optional GSM, UHF, and frequency hopping spread spectrum. 4 cameras at a 45-degree angle for documentation purposes, a downward-facing high-precision camera for photogrammetry, 4 screw mounts for an optional pole adapter. Triumph F1 is easily programmed on your computer through a user-friendly interface. There are 2 possible takeoff procedures. Shortest path can be used in open environments for faster execution. Vertical then horizontal should be used in environments with tall obstructions. Upon completion of the mission, Triumph F1 can land at the starting point, follow me, or land at any user-defined point. Landing procedures are identical to takeoff procedures. For safety, Triumph F1 will abort the mission when any of these configurable conditions are met. Many flight patterns can be saved on your PC. Up to 6 of these can be assigned to memory on the Triumph F1. Each flight pattern has its own set of parameters. In this example, we configure the flight altitude, circle radius, and the number of passes to make around the circle. Camera parameters are common to all flight patterns and can be configured for percentage overlap or a specific time interval. Finally, the flight pattern is saved to an LED on the unit. Executing the mission is even easier. Use the Flight Patterns button to cycle through the saved missions, press the Fly button, and stand back while Triumph F1 takes care of the rest. From takeoff to landing, no intervention is required. For most applications, such as mapping or construction, the data collected by the F1 will be provided as input to any number of third-party processing software. All data captured by the F1 can be accessed and transferred to a PC via the 2 SD cards in the unit. During the image capture process, Triumph F1 also saves its own location and orientation. This critical information is transferred along with the images. The data is then processed by third-party software to produce the final product, such as a 2D map or a 3D point cloud. Along with the new flight capabilities, Triumph F1 is still a high-precision GPS receiver. The motor arms can be removed and replaced with protective caps. and the underside can hold a pole mount adapter. In this configuration, Triumph-F1 can be used as a ground-based receiver, similar to Triumph-1.